Assalamu alaikum and hello everyone. We will now continue the second part of chapter 6, Force and Pressure. What is work done? Work done is when an object moves while a force is being exerted on it. For work to be done, the following conditions are required. Number 1, there is a force acting on the object. Number 2, the object moves. And number 3, the movement of the object is in the direction of the force. Look at this example. As the boy is pushing the box, there is a horizontal force being applied on it. The box moves as it is being pushed, and the box is moving in the same horizontal direction as the force. If any of these conditions is missing, then we say that no work is done. Let's look at a couple more examples. John is pushing a wall, but the wall is not moving. Is there work done by John? Let's see if we meet all the conditions required. Is there a force acting on the object? Yes, there is. Does the object move? No. If the object doesn't move, we also don't meet the third condition. So, is there work done by John? No. No work is done by John. Steve is carrying a box while walking towards a table. Is there work done by Steve? Let's do this again. Is there a force acting on the object? Yes, there is. Does the object move? Yes, it moves. Does the object move in the same direction as the force? No. In this case, there is an upward force on the box, but the box is moving horizontally. So, is there work done by Steve? No. No work is done by Steve. To calculate work done, force acting on the object is multiplied by the distance moved in the direction of the force. You can simply write this down as W equals F times D. The SI unit of work done is joule, which is named after an English scientist, James Prescott Joule. Joule is equivalent to Newton meter. Joule and Newton meter are also the SI unit of energy. This is because when we do work, we are using up the energy that we get from the food that we eat. Therefore, work done is equal to energy used. And that is why the SI unit of work done is the same as the SI unit of energy. You may also find these unit conversions useful to remember. 1000 joule is equivalent to 1 kilojoule. 1 million joule is also known as 1 megajoule. 0.001 joule is also equal to 1 millijoule. Let's try some examples of work done. Example 1. A science textbook weighs about 12 Newton. A girl lifts the textbook onto a table. The height of the table is 1 meter. How much work does she do? First, write down the formula work done equals force times distance. Second, put in the numbers. Work done equals 12 Newton times 1 meter. And finally, the answer would be 12 Newton meters or 12 joule. Don't forget to write down the units in your answers. Any of these units is correct, so just choose one between the two. Example 2. A man needs a force of 3,500 Newton to pull the box. He pulls it at a distance of 20 meters. How much work does he do? Pause this video to try this question yourself. Work done equals force times distance, which is equal to 3,500 Newton times 20 meter. And finally, the answer is 70,000 Newton meter or 70,000 joule. From these examples, who does more work? Is it the girl or the man? It's the man. Why? It is more difficult to move a big box than a textbook. To move a big box, the man requires 70,000 joule or 70 kilojoule, while the girl only requires 12 joule to move the textbook. Therefore, the man does a lot more work than the girl. If you push a sharp pencil and a blunt pencil into an eraser, which one would go deeper into the eraser? It would be the sharp pencil. Why? Because the sharp tip of the pencil has a smaller surface area that comes in contact with the eraser. As the area is smaller, the pressure is greater, and so allowing the pencil to go deeper into the eraser. Likewise, the tip of the blunt pencil has a bigger surface area, so it exerts less pressure and cannot go deep into the eraser. Pressure is defined as the amount of force acting per unit area. To calculate pressure, force acting on the object is divided by the area of contact. You can simply write this down as P equals F over A. The SI unit of pressure is Pascal, which is named after an English scientist, Blaise Pascal. Pascal is equivalent to Newton per square meters. Another unit of pressure is Newton per square centimeters. It is important to understand that the amount of pressure depends on the area of contact and force applied on the object. Let's say the force applied on an object is kept constant and the area of contact decreases. The pressure exerted by the object will increase. However, if the force applied is kept constant and the area of contact increases, the pressure exerted by the object will decrease. Now, let's try some examples. Example 1. Calculate the pressure on the floor when the brick of weight 30 Newton is placed as below. First, find the area of contact on the ground. This is the area of the brick that is in contact with the ground. So, area is equal to 0.03 times 0.01 meter, which is equal to 0.0003 meters square. Second, write down the formula pressure equals force over area. Then put in the numbers. So, pressure equals 30 Newton over 0.0003 meters square. And finally, the answer is 100,000 Newton per meter square or 100,000 Pascal. Again, don't forget to write down the units in your answers. Any of these units is correct, so just choose one. Example 2. The figure below shows a 24 Newton box on the floor. Calculate the pressure exerted by the box on the floor. Show your working. Pause this video to try this question yourself. This is the area of contact on the floor, so write down area equals 4 meters times 2 meters. You should get 8 meters square. Then, write down pressure equals force over area, so pressure equals 24 Newton divided by 8 meters square, which is equal to 3 Newton per meter square or 3 Pascal. Example 3. An elephant and a lady wearing high-heel shoes are standing on the floor. Which of them would give more damage to the floor, the elephant's foot or the lady's heel? Say the weight of the elephant is 50,000 Newton and the area of its foot is 1,000 centimeters square. Calculate the pressure. Pressure equals force over area. This equals 50,000 Newton over 1,000 centimeters square. And you should get 50 Newton per centimeter square. The weight of the lady is 500 Newton and the area of the shoe heel is 1 centimeter square. Now find the pressure. Pressure equals force over area. This equals 500 Newton over 1 centimeter square. And you should get 500 Newton per centimeter square. So, which of them would give more damage to the floor, the elephant's foot or the lady's heel? It would be the lady's heel, because the pressure exerted by the shoe heel is 10 times greater than the pressure exerted by the elephant's foot. Now let's see how pressure can be applied in our daily lives. The studs on football boots decrease the area of contact with the ground. This increases the pressure, causing the studs to easily sink into the ground, so preventing the player from slipping. A bulldozer uses steel tracks that have a large surface area. Although the bulldozer is heavy, its weight is spread over a large area, so the pressure on the ground is smaller. Therefore, the bulldozer does not sink easily into mud or sand. The reason why sharp knives can cut more easily and why we use the tip of the nail and not the flat surface of the nail is also because they have smaller area of contact and so producing greater pressure on the surface. And that is the end of chapter 6. Well done everyone. Thank you and see you in the next topic.